All right, and so one question we can ask ourselves, if we have an E2 reaction, which one of the products is going to be our major product? And so let's take this haloalkane as an example. So we've got some options, right? The first thing you want to do is you want to identify your beta hydrogens. And we're going to go ahead and react this with sodium methoxide. So the first step, you find your beta hydrogens. So in this case, we have a hydrogen over here, along with two more, but they're all the same. So we can just take a look at one of them. And then we also have a wedged hydrogen over here. And then the second thing that you're going to want to do is take a look at your base. If your base is bulky, we're going to get the less substituted alkene. If your base is not bulky, you're going to get the Zaitsev product, right? The more substituted alkene. And then, of course, when we're thinking about this as well, we have to think about the stereoselective. Product, in which case the trans is favored over the cis product. And so we have, in this case, a non-bulky base. So it can indeed still eliminate out this hydrogen to form this following product. However, this product would end up being the minor product. Of course, my bad, I drew this extra methyl group. That methyl group should not be there, right? So since we're not using, if it was a bulky base, this would be the major product, but since it's not a bulky base, this is the minor product. So after you found the beta hydrogens, found out what your base is, the third step is to look at the anti-conformer of the hydrogen and the leaving group. And so we can redraw this molecule right here. Right, and we can see that our hydrogens are not anti to one another right now, and so we need to rotate the molecule to make them anti to one another. And so we can think about rotation about this bond. I usually like to put the hydrogen and the bromine in the plane of the board. I find it's easiest to see that way, but if we did this, this methyl group would be sticking out, this hydrogen in the back would be sticking in, and then this ethyl group would be sticking out, and then the methyl group would be sticking into the back of the board. And so now that we're set up for our E2 reaction, our base can come in and perform the E2 reaction. And then we think about which things are going to be on the same side. This methyl and this ethyl group will be on the same side, and this hydrogen and this methyl group, the hydrogen and the methyl group will be on the same side. And so that would end up right there, and this would be our major product. Right? It's the more substituted alkene, and since we have a non-bulky base, this is what we're going to go for, right? Again, that's Zaitsev's rule. And if we take a look at our anti-conformer, we can see that these groups will end up being on the same side of one another. And so overall, there's a lot to consider. With these E2 mechanisms. And so you really want to practice these in order to get a good understanding.